Welcome to the Reimagined Energy podcast. Today, we're diving into the water, literally. Artemis Technologies has developed the world's most advanced zero-emission electric hydrofoiling vessels. These e-foilers promise 90% greater energy efficiency than conventional ferries, near-silent rides with minimal wake. We'll also explore what this technology means for cities, commuters, and even sustainable tourism worldwide. I'm your host, Maria McGowan. This is what's coming up next. Hi, David. Welcome to Reimagined Energy.
Hi, thank you. It's great to be here.
It's great to have you. I've been reading about Artemis Technologies, and for those people listening in or watching, tell us about your company.
Yeah, sure. Artemis Technologies. Well, maybe go back to kind of the history of where we came
Mm-hmm.
from. We were originally an America's Cup racing team called Artemis Racing. So we were competing in these high performance catamarans, building those boats in San Francisco and racing in Bermuda in the America's Cup in 2017. And developing these kind of lightweight composite yachts using hydrofoiling technology, huge efficiency gains in terms of yacht racing. And we wanted to bring that technology, that game-changing technology, into the wider commercial maritime sector. So we founded Artemis Technologies back in 2017, based in the UK, in Belfast, and we're developing a range of electric foiling craft.
That is really cool. And so now you're breaking through. So you've had a lot of design breakthroughs, with the e-foiler vessels, like that's what they're called, that are zero emission and, they have a minimal wake. So how do these innovations, differ from traditional electric ferries or vessels?
Yeah, so going back to that kind of America's Cup heritage and really
Yeah.
hydrofoiling race boats. So a hydrofoil, for people that don't know, it's basically like a wing under the water. So when a
Mm-hmm.
boat accelerates, it creates lift, picks a boat up out of the water and reduces the drag. And that's really important, particularly when you're looking at electrification, because water is 800 times denser than air. So you hear about range anxiety on cars. Well, it's far worse actually on boats. So simply putting a battery in, say, like a fast ferry here in New York where I'm based, if you do that, because they use so much energy to operate at high speed, they're significantly limited by the range and the speed that they can operate. And so it's just not viable. So what we've done is basically brought this hydrofoiling tech, this kind of a drag reducer, efficiency gainer. And so with our boats sort of popping up out of the water, it means for a given amount of batteries on board the boat, we can go significantly further and faster. So it really unlocks the potential for electrification and decarbonisation of kind of high-speed vessels. So passenger ferries like you have in Halifax as well, up in Nova Scotia, San Francisco, New York, and London as well, and then also high-speed vessels operating in ports and harbours, so pilot boats, crew transfer vessels operating for offshore wind and energy, search and rescue, coast guard. So
Well, it's
lots of
amazing.
applications.
Yeah, well, the GP event was here recently, and I think it drew like one of the highest crowds, and for the whole event. But the residents here, we got to see what e-foiling looks like, well, not or foiling looks like, on the water, and it was really quite remarkable and fast.
Yeah, it's though. Well, actually, one of the boats used in Sail GP is our America's Cup boat from Bermuda. So Sail GP was really kind of a development of that technology
Cool.
raced in Bermuda. And we have at Artemis Technologies, we have a consulting business as well as our e-foiler vessel business and a full motion platform simulator. So a number of the teams will actually come to Belfast and train on our simulator in between the races. But yeah, Sail GP is really exciting, incredible machines going 50 plus knots, three times, four times the speed of the wind, huge jump in efficiency. But what I would say is, sometimes you see those boats sort of crashing down and things like that. And that's kind of the complete opposite to the engineering approach that we've taken with our e-foiler boats. On Sail GP, The
They're
operator actually
racing.
has to fly
Yeah.
the boat, and they're racing. So with their
Yeah.
foils, they want them to be as efficient as possible. And an efficient foil is basically a really thin and small foil.
Hmm.
And when you go small and thin, it means you become less stable. So that's why they're
Okay.
having. But you're kind of on that. You're kind of on that edge between speed and stability. Whereas with
Yeah.
us, we're developing our e-foiler boats really to be robust, reliable, stable, and for full commercial operation.
Mm.
Plus, the our flight control computer is far better at flying these boats than the human could ever be.
Interesting. Now, your data, at Artemis, of your e-foilers, they use up, they say they use us up 90% less energy versus conventional vessels. So, how does foiling technology allow for this? And what does the 52 nautical range mean for real world operations?
With that efficiency saving, yeah, it's a kind of a combination of two things really. There's the drag reduction by
Yeah.
basically lifting the hull out of the water and flying on the foil, so using less energy because there's less surface area going through the water. Plus, because it's a fully electrical system, and we're 97 or so percent efficient from battery right through to the propeller, and about 70% or so
Hmm.
efficient with losses. And compared to kind of an ICE, an internal combustion engine, um, standard sort of drive unit on a normal boat, they're probably somewhere around 22, 24% in terms
Hmm.
of kind of the propulsion system. So we've got this amazing efficient electrical system, plus the drag reduction of the hydrofoils,
Right.
plus you're flying above the waves, which means you have less interaction with waves than a normal boat does. So it's kind of a combination of all those different things.
Yeah. Yeah.
And kind of the big question I get all the time is, well, what happens with these boats in waves? Well, actually, they always outperform a standard boat because you're getting that additional stability and that reduction in sort of drag because you're
Right.
hitting less of the waves than a standard boat.
Hmm. And then you mentioned, like we were talking earlier, you mentioned the 52 nautical mile range. Is that kind of the average, or what does that mean in operations?
Yeah, that's the foiling range. So
Okay.
typically, the cruise speed at foiling range is around 25 knots.
Mm-hmm.
So in flat water, that the kind of EF12 range, depending on the spec of the boat, will be around
Mm-hmm.
that 50 nautical mile range at high speed. It will be more than double that if you're going slowly. So if you're doing sort of 6 knots, you can go a lot further. And then with the larger ferry platform, we're able to push that range up to closer to 70 nautical miles at high speed. And again, if you're going slowly, it'll be twice, more than twice that distance you'll be able to do.
Right.
And so I think it's for a pilot boat operator, typically they'll be doing anywhere between sort of 5 mile and 20 mile round trip typically.
Mm-hmm.
So it means that for our electric pilot boat, they can do multiple journeys, and then before they have a requirement to charge. And just going on to that, the range is one thing, but we're using fast charging systems with these boats as well. So we use a
Right.
CCS2 connector on the small boat.
Mm-hmm.
So the same charge you would use on your electric car, and we can charge that boat in an hour. And then we're
Yeah.
using the MCS standard electric charging system on the larger ferry too, so we can charge in under an hour with that technology.
Well, let's talk about charging because, what steps are underway to build scalable charging infrastructure? These fleets, they need to be they have to be built at speed, but also they have to be scalable as well.
Yeah, and we're really leveraging technology from the automotive sector. So we're kind
Hmm.
of bringing that technology into the maritime space. The same with the electric drive unit in our boat. It's actually um, the technology was used in motorsport, and we've kind of re-engineered it and marinized it, made it a
Hmm.
bit cheaper to fit into our vessels. And so we're really leveraging that charging technology from the automotive space too. Um, and I think the charging can be a challenge. I
Yeah.
think, but that's the other exciting thing about our technology is that because we're so much more efficient, it
Yeah.
means that our boats need far less energy than an electric floating vessel too. So if you're looking at a big fleet replacement like in New York or in Halifax with their
Hmm.
potential plans around the 5 electric ferries that they have, because we're using 70 to 80% less energy and actually operating at a higher speed, it means that we need far less in terms of infrastructure. Typically, there's with charging, you can either have a dispenser on the pontoon connected to the grid where you have the
Hmm.
available power. But in locations where it's challenging, in island locations or small marinas, you can actually have an energy storage system on shore. So
Right.
basically a battery in the box. So it means that that battery will take a slow trickle charge from the grid, charge
Yeah.
overnight, keep charging during the day. And so when the boat comes in, you have that stored energy and you can do a really fast charge into the vessel when you need that power.
Nice.
So yeah, that I think charging is definitely part of the challenge, and
Hmm.
it's not simply a case of looking at buying a boat. You really need to think about the whole system together when you're looking at buying this or implementing this technology.
Yeah, it's all encompassing. So, in cities like Halifax or New York or San Francisco, how can your vessels, unlock new commuting routes, let's say, or relieve road congestion, at these growing cities, but also create resilient mobility networks. So, what's your solution to all that?
Yeah, I think typically ferry systems have been heavily subsidised
Hmm.
by by um, by public transit agencies,
Right.
and I think there's a bit it's a bit unfair because I think when you're looking at the comparative costs with rail and with buses and things, you're not taking into account the cost of the roads and the bridges and everything else.
Right.
Whereas with the ferry, the water's there, it's free, it's available,
Yeah.
and actually
Exactly.
bringing in ferries is the fastest way to um, add capacity to busy water-based cities and towns.
Hmm.
And the cool thing about our technology is because we're using so much less energy, we use the fuel costs are much lower. Because in an electric vessel, the service and maintenance costs are much lower too. So on busy routes in New York, operations are saving over $1 million a year per boat just in terms of the fuel costs. So when you consider that over the lifetime of say 20, 30, 40 years, implementing this technology actually means it's going to be cheaper than the current diesel alternative over the lifetime. But going back to your question, because these boats are clean as well, and because the boats
Hmm.
fly above the water, they produce very limited water wash and wake. So the boats can operate at high speed, whereas in locations where before maybe there was a speed limit because of that water wash, either damaging shorelines or causing disruption to other water
Hmm.
users. So in Belfast Harbour, there's a 6 knot speed limit. We actually have permission to go 25 knots. So I guess the reduction in the costs of operating these boats compared to traditional diesel vessels, the fact that they can operate at higher speed and avoid speed restrictions, plus they're far quieter and less noise and pollutions, mean that they can operate in locations where perhaps ferries weren't able to operate because of impact on local communities and health.
Hmm.
And so it really does, all those things combined really does mean you can rethink cities can rethink about how they use their waterways.
Well, it's interesting because also the pollution, you mentioned the noise pollution, but also, there's no risk of diesel going into the water or anything like that.
No,
Sometimes,
no. So it's good for the health of citizens that
yeah.
live close to these ports, and typically they are the probably low income disadvantaged communities are generally
Mhm.
put by the water or put near these ports. But also for local wildlife too, it's really important that
Mhm.
implementing this technology. There's no diesel spills, there's no oil going into the water. The vessels are completely zero emission in operation, so it significantly improves the health of both local communities but also nature.
Right. Well, I know that the Atlantic and also the Pacific, the waterways, it can be cold, it can be choppy, or there can be in the Caribbean, for example, there could be environmentally sensitive zones. So what testing has verified, the adaptability of your vessels being in these areas?
Yeah, I mean, that starts from the drawing board when you're developing and
Hmm.
designing this technology. So we've been operating the boats in freezing conditions, and we had one of our vessels here in New York, and it was snowing.
Yeah.
We were taking people out of the water every day. Pretty cool. We actually ended up when we brought the boat over to North America, our demonstration boat. We took it to Savannah for the Passenger Vessel Association conference in the US, and it
Hmm.
was the first time that Savannah had had snow in about 10 years. So
Oh,
the whole
wow.
thing was kind of shut down, and
Yeah.
the guy, the crane operator, didn't want to work because he didn't want to work in the snow. They weren't really sure what to do.
Yeah.
And so we've had the boat operating in really cold climates, and the technology is designed to handle that. But equally, in places like the Middle East or the Caribbean, where
Hmm.
you get incredible, really warm water temperatures and air temperature, the battery system has a kind of thermal management system. So it kind of cools and heats the batteries depending on the location where you're operating. And
Right.
I think being from the UK and being surrounded by the Irish Sea, the North Sea, some pretty challenging
Yeah. Same
conditions there.
environment, right? Yeah.
Same environment, and all kind of high speed passenger ferries within the UK have to meet the international high speed craft code, which is
Right.
basically the highest safety threshold for passenger ferries. And so I think it's in our nature to develop technology living in the UK and operating on those waters to develop something that's robust, reliable, and can handle some pretty challenging sea states. And with the pilot boat, with the crew transfer vessel for offshore energy as well, those vessels have to be able to operate in that North Sea conditions and operate every day.
Hmm.
So we've really developed this technology from the bottom up to make sure that we can handle those challenging offshore conditions. And I'd say that really separates us from other people developing similar technology, is that that's really been our primary focus. There's other companies that have maybe developed something from the leisure market, which is kind of a lower barrier to entry. There aren't really too many rules, but our focus has been primarily on those commercial operations operating offshore.
Hmm. We talked earlier on about, the comfort level, about, it eliminates seasickness and a lot of movement because of that there's less drag and so on. So explain that. You were saying that the fin, is that what it's called, or the
But
actual
the foil,
the
yeah. So the
foil
wing under the
is
water.
wider?
So
Yeah.
yeah, basically because you're flying above the waves, and then within the foil itself, you have these movable appendages like
Right.
ailerons or like flaps on an aeroplane. So it's very, very much like an aeroplane under the water.
Hmm.
And there's a closed loop control system which is feeding into basically making the flaps move to maintain that optimum ride height above the boat. So when the pilot, we call them, the driver, the
Right.
operator of the vessel, they will just accelerate on the 12-meter boat. They'll get to about 14 knots. There's a button. They press takeoff. They push that. The flaps engage, create lift. The
Yeah.
boat will pop up to the optimum ride height, which can be set by the operator depending on the sea state. So if it's
Okay.
flat water or choppy, or if
Waves.
there's kind of swell waves, you have different modes on the vessel. And that kind of flight control system is completely autonomous. It's just you just take off, land, that's it. All the operator has to do is steer and throttle as they would
Cool.
normally. And because you're kind of flying above the waves, you have significant reduction in sort of the accelerations, so the bumping around. So it's far more enjoyable, far more comfortable, and really reduces the effects of seasickness in some pretty big seas. So
Hmm.
even in New York, I know here that people are put off by the kind of bumpiness and rockiness of the conditions here, even just in New York. So that really is going to be a game changer. And our customers are really excited by the potential of, because of that improved customer experience, it's actually going to drive ridership. So there's the dual benefit of reduction in kind of total cost of ownership, but also driving more revenue because people are really going to want to be on these ferries and they're going to enjoy it and come
Yeah,
back.
that is interesting. Well, looking ahead, past 2025 and beyond, what partnerships or pilot programs are you working on right now? It could be around, I hear your luxury resorts you're looking into coastal cities. So what's on the docket for the next few years for you?
So we went into serial production of our boats last year for the 12-meter size. So the EF12 pilot boat, the EF12 Escape, which is our luxury water taxi. And so we
Hmm.
started delivering those vessels to customers towards the end of last year. So we kind of come out of this heavy R&D phase,
Hmm.
sort of 5 years developing the technology into commercialization. And then we are currently building the first three of the larger EF24, so the 150 passenger ferry. And the first one's going to hit the water towards the end of this year, beginning of next year. So that's a really exciting moment for us. It's getting these first of class boats on the water. Um,
Awesome.
and then we are scaling our business. We're growing internationally. I I actually moved out to New York in December last year to set up our Americas division. We've seen a lot of interest over here, both in the US and in Canada and South
Mm.
America too. We're establishing manufacturing partnerships around the world. So we've announced Delta Marine in Washington State, and then we're also talking with other partners both in Canada and on the east coast of the US too, and then expanding the other way. So we're delivering boats to customers in Europe, the Middle East, and then there's lots going out in Australia as well, and Asia. So it's that challenge of kind of coming out of that valley of death, where you kind
Yeah.
of heavy investment in R&D, and you have to commercialize the technology, and then scaling as fast as we can.
Yeah.
So
Well,
it's
yeah, it's
you always
exciting.
think it's going to get easier, but it never does. It always just it just keeps building and building. But it's
Yeah,
exciting.
it is. It is. Well, thanks, David, for joining me today. It was really interesting to have this conversation about, e-foilers, and hope to see you guys in Halifax or Atlantic, Canada somewhere, and actually ride on one. I know I've had an invite, but couldn't make it. But all the
Yeah,
best.
hopefully. Thanks very
Yeah.
much. Cheers. Bye.
That wraps up our conversation with Artemis Technologies, who are proving that zero emission mobility on water isn't just possible, it's here. Thank you so much for listening to the Reimagined Energy podcast. Be sure to follow, share, and join us next time as we continue exploring the ideas and technologies moving us toward a cleaner, smarter future.